Jessie Sikora is a current master's student at Northern Illinois University. Before matriculation, she worked at a variety of national parks, including Big Bend, Crater Lake, Petrified Forest, and Badlands, to name a few. Beavers and hydrology are relatively new fields to her, so she is excited for this opportunity to receive feedback and suggestions. So welcome, Jessie, to the stage.
Like Adam said, hi, I'm Jessie Sikora. I'm a master's student at Northern Illinois University. Today I'll be talking about my master's research, what I've accomplished so far, and what I'll be doing this upcoming year, considering measuring beaver dams and their impacts at Nachusa Grasslands, implications of beaver-facilitated stream restoration. Okay, let's get right into it and talk about why we have this obsession with beavers. Why have a whole conference dedicated to beavers? They are a two-worded term that encompasses the magic that is the beaver. Everyone say it with me now. They're... Yes, great. Someone in the back, ecosystem engineers. I would throw you candy, but unfortunately, I'm a graduate student on a budget. So continuing on with ecosystem engineers, what do I mean by ecosystem engineer, and why is it important? Beavers change stream dynamics through their damming behavior and create novel wetland habitat for other organisms like fish and macroinvertebrates, as well as providing other ecosystem services like introducing waterway sinuosity, promoting water storage, driving sediment deposition, and reconnecting incised streams to the landscape's floodplain. It is widely indicated throughout the literature that lateral woody debris in waterways impact their flow. Dams have exhibited the ability to reduce stream discharge by 100%, effectively converting streams to hyporic zone and increasing water storage through groundwater recharge. Further, dams have shown to double the rate of fine-grained sediment deposition and increase the storage of particulate organic matter along the stream channel and bank. Most of this literature, however, is derived from forested ecosystems, but I'm interested in how these variables may be different in grassland ecosystems, where stream flow rate is greater and groundwater recharge rates are slower. This affords a unique opportunity to bolster freshwater reserves. Specifically, the mechanisms of water storage and fine-grained sediment deposition are vital foci in grassland streams because of the historical systematic replacement of grasslands into agriculture. So now let's talk about the impacts agriculture has on stream systems specifically. Generally, what we see in agricultural practices is the straightening of streams and removal of obstructions like riparian vegetation to increase efficiency and drainage. This removal of obstructions increase erosion and has a cascading effect on the stream system. In this first picture is a great example of stream straightening, or what we call low to no sinuosity. Low sinuosity allows an increase in stream velocity. And in this picture is a good example of what happens in a stream with a high velocity. Faster streams in size are cut into the stream bed, leading to rapid removal of sediment and nutrients, and eventually creating bedrock-dominant stream beds that are uninhabitable to macroinvertebrates. Further, this system loses its ability to receive and store freshwater in the landscape, resulting in flash flooding events. These symptoms of agricultural stream degradation are endemic throughout the state of Illinois, where pre-European settlement, Illinois contained 36 million acres of prairie, 21 million of which were tall grass prairie. Since European settlement, 99% of tall grass prairie has been replaced with agricultural land. Today, remnant tallgrass prairie makes up 1/100% of its original extent in Illinois. It's no wonder that tallgrass prairie is one of the most critically threatened ecosystems. But good news, there is hope yet. Enter Nachusa Grasslands. Grasslands Preserve, located in Franklin Grove, Illinois, encompassing 3,600 acres of remnant tallgrass prairie, as well as varying stages of grassland restoration from agricultural degradation, and 10.4 kilometers of flowing streams. Nachusa Grasslands is a state-of-the-art research site for restoration managed by the Nature Conservancy. The landscape which makes up Nachusa was impacted for over 100 years by agriculture, and even now with restoration efforts, Nachusa is a postage stamp of native tallgrass prairie amongst a sea of agricultural fields of corn and soybeans. Because of this, all of Nachusa's waterways are connected to agricultural waterways. Enter the beaver and its unlimited potential for restoring waterways. Beavers could be used as a restoration tool in Nachusa, but I wasn't convinced that there would or could be any significant damming activity throughout Nachusa streams. In a sea of grass with select trees and shrubs, how could beavers make any substantial dams? So my first research question was, what is the abundance and distribution of beaver dams at Nachusa? My hypothesis? I'm so glad you asked. The beaver dams just aren't going to be there. No way I'm going to find anything significant. So to prove my hypothesis, my methods, I and a field technician suited up in waders, walked through all 10.4 kilometers of Nachusa's flowing streams. Guess what we found? We found beaver dams everywhere. Yeah, I know. Thank you for I rejoiced. My advisor and I had a huge party on a dam. It was glorious. I had a pool of beaver dams to ask more questions about beaver-facilitated restoration and agriculturally degraded systems. Sorry, degraded streams. Same. Okay, so how big of a pool, you ask? How many beaver dams did I find? Throughout the 10.4 kilometers of flowing stream, we found and mapped 148 beaver dams. This is roughly 10% of the dam density generally found in forest streams, which is unsurprising due to the lack of woody resources on the landscape and the beaver killing practices held by neighboring agricultural managers. I randomly selected 25 dams to study the potential restorative impacts beavers are enacting in these waterways. Let me take you on a walking tour of some of the streams at Nachusa, along with dams I was finding, to show you the agriculturally degraded streams I'm working at in Nachusa. Don't worry, waders will not be needed. So here's our first dam. You can see that it's pretty breached. And then you also see the stream bank and how disconnected it is. The floodplain isn't really connecting to the stream at all. And here we have a pretty intact dam. Look how pretty. But then the floodplain is way up there. I do like this dam. But then again, you see the history of incision along the channel and how disconnected the floodplain is. So now that I've answered my first research question, that yes, there are beaver dams at Nachusa Grasslands, I can ask questions about how effective these dams are at restoring the streams they are constructed in. To that end, my next research question is, how does beaver dam volume impact water retention? To answer that question, I'll be measuring the change in discharge. Also my hypothesis. I assume the greater the dam volume, the greater the possibility that the dam will hold water in the area. Measuring the change in discharge from above and below a beaver dam will help answer the question of how effectively a dam sequesters water and bolsters water retention within and surrounding that section of stream. I will measure discharge using the standardized midsection method, where I'll establish a line perpendicular to the stream flow at an area where the stream is normalized, whatever that means, hydrologists are weird, and establish points of measurement along that line. At those points of measurement, I measured the distance from the bank, the depth of the stream, and using a current meter and USGS pygmy meter, the velocity at 6/10 of the depth. Also, another interesting thing about hydrologists, they measure in feet and tenths of feet. Why? Why? Okay, these metrics are then put into an involved equation I will not subject you to, which will then spit out the stream discharge or how much water is moving through the channel. And then getting at the differences between the above and below, we can get at how much water is being retained at that dam. Okay, moving on to my next research question. How does Beaver Dam volume impact the sediment deposition? My hypothesis, again, pretty straightforward. The greater the dam volume, the greater the potential that the dam is helping with sediment deposition. To answer that question and to accomplish these measurements, I'll be piggybacking off of the midsection measurements taken for stream discharge. So again, using this midsection method, that was weird animation, sorry. Using the same points, I'll use a drip bottle to capture fine-grained sediment at 6/10 of the depth. This is predominantly the area of the channel where fine-grained sediment is transported. Measuring the change in suspended sediment above and below a beaver dam will help answer the question of how effectively a dam captures the fine-grained sediment associated with nutrients and particulate organic matter and bolster stream bed and bank restoration in that section of stream, as well as improving water quality and clarity. During the course of this project, I'm working with land managers who have control over how beavers are managed in and around Nachusa. And so this work will directly speak to the restoration challenges they face. Little was known or understood about beavers in the area, and this will help build the knowledge of beavers' roles in the area and in grasslands in general. Working within a landscape predominantly agricultural means that the beavers whose dams I'm studying are trapped out and killed by local farmers. Better understanding the roles beavers occupy could help with local beaver conservation. To zoom out to tallgrass prairie grasslands globally, the reclamation of agricultural land for the sake of grassland restoration is vital to saving this critically threatened ecosystem. Understanding how beavers could play a role in the effort could help grassland managers everywhere. Acknowledgements. I stand on the shoulders of giants. I think good science comes from a community, so I would like to thank my community, my advisors, my lab members who have seen all sorts of iterations of my research. At one point, I was thinking about putting collars on beavers. It was a crazy time in 2020 for more reasons than just that, but y'all know. I'd also like to thank my field assistants, Lizzie Small and Ethan Dye. Questions?
Nice work. Thank you for sharing the beginnings of your work. I mostly want to make a comment on the pygmy meter. Have you started using the pygmy meter to measure discharge?
I have.
Are you finding any issues with it getting clogged with sediment in its spinning parts?
I have not, but I've only started working at Clear Creek, so called the name because there's not much sediment in the stream, so I have yet to face that issue.
We have, and we have switched to a Doppler meter because beaver wetlands typically have very low flow above their dams and a little bit faster below because of how that works. But we were finding it to be a challenge. So a Doppler meter reduced that or eliminated that challenge completely. So if you have access to one, it might be worth trying both or at least looking at it as a backup if you need it. Because usually they're highly sediment-rich systems. So,
right.
Yeah.
Good
luck. I can't wait to see your research.
Thank you. Maybe I'll be invited to the next BeaverCon and I'll be published.
Okay. I'm also a graduate student. I'm looking at, historic and current beaver populations, but I was just wondering how, like, your normalized flow rate, like, or discharge, how far upstream, like, from the dam were you going?
That's a good question, and I used normalized in there because it really depends on how much the dam has impacted the area. So I'm not taking these measurements anywhere where there's a pool. So right now it's like I'm going 7 meters upstream or downstream to get at where the channel comes back to its normal state. So it really depends. Like, I wish there was like a 5 meters, and my committee members were like, what do you mean 5 to 10 meters? Is it 5 or is it 10? It's like, you don't understand. Hydrology is weird. You kind of have to you have to feel for it, you know? Don't be shy.
Yeah, we're all just picking the farthest apart to make Adam run the most to bring the microphones. So everyone's here for water storage. The third question on water storage. I'm wondering if you could talk a little more about what you expect from the data. So if you're measuring your volume flow rate in and your volume flow rate out, the pond could still be storing water, obviously, because it's a pond when those are equal. And if they're different, then is that stored or is that water going someplace that you aren't accounting for? So what do you mean by water storage? Where's the water being stored?
Yeah, so I'm looking at the change in discharge because I'm allowing the opportunity for the water to be stored in different areas. So either via a pond, or it's percolating into the ground, or it's just laterally being stored on the landscape. Does that answer your question? Kind of, maybe. Okay.
Your research has elements of research I did about 4 years ago. And so if you wanted to talk after this, it'd be fun to talk to you about it. But standardizing, measuring different beaver ponds to one another or to themselves, we wrestled with that a lot and came to a pretty good answer. So if you're not already set with 7 meters, or you have very much varying different sizes of ponds upstream of your dams, you could talk to me because I've got some ideas for you.
I can't wait. That's what I came here for.
Excellent presentation, by the way. I did have a question about the farmers. Have you had any luck changing the farmers' minds so they weren't so apt to go out there and remove the beaver and maybe looked at beaver as more of an asset? Or can you just elaborate a little bit on that?
Yeah, because of the panorama, I haven't had much opportunity. Pandemic, sorry. I haven't had much opportunity to do any of like the social. There haven't been many social events. Usually in Nachusa Grasslands, the researchers have opportunities to socialize with the neighboring land managers, which just hasn't happened until recently. So it's still an ongoing thing of like trying to make those connections and have those conversations, which I know it's like a little hard. So.
Okay, we have two more questions, and then we'll have to move on.
I was wondering, do you know why they built these dams in these grasslands? Because as far as I understand, they built the dams in the forest so that they can easily find the trees around and to have like a stable water level for their lodge. Did you also find these lodges in the grasslands? Because we in the Netherlands, we barely have these dams, but we have similar landscape. But there they don't build these dams.
Yeah, that's a very good question. I did find a complex of lodges in. So there are like a few streams. So one of the streams has a complex of beaver lodges, but then the other stream, Clear Creek, where the dams are older and it seems like the beavers aren't coming back to those areas. I found a lodge that was torn apart, and I think maybe beavers aren't going back to that area, but they are there. I don't know why they're there. I think mostly because they like building, and it's a habitat that's maybe not being used by other beavers, and maybe, I don't know, they're the weaker beavers, and so they're like, okay, well, we're gonna stake out these streams. These are ours. And like, all right, man, no one's fighting you for those. You can have them. I don't know, maybe something like that.
Great presentation. Thanks so much, Jesse. My question on the transition of the ecosystem, how is that going to change? How do you project that will change over time with the addition of the beavers? I mean, besides the sedimenting and, you know, the lifting of the bottoms of the ponds, et cetera, but what do you think the successional system of the biota will be?
That's a great question. So one of the great things I love about working at Nachusa is I can see the different stages of restoration. So in the area where restoration has been going on since the 60s, I can see that the beaver dams are very prominent. This is where like the lodge complex is, and I can see that the streams are deeper, they're slower, and there are like a lot of beaver channels. It's there's a lot more wetland areas in that area. And then up north, it's like these were recently bought plots of land. And so you see like the incised, very short, straight, not short, not wide, but narrow. Thank you. Oh my gosh. The narrow streams and canary reed grass everywhere. So I imagine that the newer ones will eventually change over into the streams that I'm seeing where restoration's been going on for 60 years. Are there trees? Oh no, so like they actually, Nachusa, part of the restoration is they do fire regimes to make sure that there isn't tree encroachment. I got there. But I think maybe they'll bring willows back to the area. The beavers, they tend to do that wherever the beavers are like crazy happening. There are willow stands around the streams. But they're all saplings, they don't get much bigger. That was the last question, right? Great, thank you guys so much.